Imagine the entire universe concentrated into a point smaller than an atom. Roughly 13.8 billion years ago, this point expanded rapidly in an event we call the Big Bang. It wasn't an explosion in the traditional sense, but rather a rapid expansion of space and time itself. In the first fractions of a second, the universe was an inferno of energy, far too hot for even atoms to exist. As the universe expanded, it cooled, and energy began converting into particles. These particles, like quarks, electrons, and neutrinos, formed a chaotic soup. Over time, the universe continued to cool, allowing for the formation of the first protons and neutrons. These particles eventually came together to form the first atoms, primarily hydrogen and helium, setting the stage for the birth of stars and galaxies. As the universe cooled after the Big Bang, a remarkable transformation took place. The primordial soup of elementary particles began to combine, forming the first atoms. This era, known as recombination, marked a significant shift in the universe's history. Before recombination, the universe was opaque, with free electrons scattering light. As the universe cooled, protons attracted electrons, forming neutral hydrogen atoms. With fewer free electrons to scatter light, the universe became transparent. The light that had been trapped for hundreds of thousands of years was finally free to travel, reaching us today as cosmic microwave background radiation. These atoms, primarily hydrogen and helium, served as the building blocks for stars and galaxies. The early universe, though teeming with newly formed atoms, was not a uniform expanse. Tiny fluctuations in density acted as seeds for larger structures to form. Gravity drew in clouds of hydrogen and helium gas, forming massive clouds called nebulae. As gravity pulled the gas inwards, the clouds contracted and heated up. Eventually, the core of these collapsing clouds ignited nuclear fusion, the process that powers stars. The first stars were massive and short-lived, enriching the surrounding gas with heavier elements when they exploded as supernovae. These stellar explosions seeded the universe with the ingredients for planets and life. As stars formed, they clustered together under gravity, giving rise to galaxies. Section 4, A Cosmic Dance, the birth of our solar system. Within the Milky Way galaxy, about 4.6 billion years ago, a giant molecular cloud began to collapse under its own gravity. As this cloud contracted, it started to spin, flattening into a rotating disk with a bulge at the center. The intense heat and pressure at the center ignited nuclear fusion, giving birth to our sun. The remaining material in the disk continued to swirl around the newborn sun. Over millions of years, dust grains collided and stuck together, forming larger objects called planetesimals. These planetesimals continued to accrete material, eventually forming the planets we know today. Closer to the sun, rocky planets like Earth formed, while farther out, gas giants like Jupiter and Saturn took shape. Section 5, Life Finds a Way, the emergence of life on Earth. While stars and galaxies continued their cosmic dance, a remarkable transformation was taking place on Earth. The precise details of how life arose remain a mystery, but it began in the early oceans billions of years ago. The early Earth was a harsh environment, bombarded by asteroids and comets with a toxic atmosphere. Yet in this primordial soup, the building blocks of life emerged. Simple organic molecules formed spontaneously, eventually giving rise to the first self-replicating molecules. These early life forms evolved and diversified, transforming the Earth's atmosphere and paving the way for more complex life. Section 6, Expanding Horizons, the Ever-Evolving Universe. Our journey through the universe highlights the interconnectedness of cosmic events. The atoms in our bodies were forged in the hearts of stars, and the molecules that make up our DNA were once part of ancient interstellar clouds. We now know that the universe is constantly expanding, with distant galaxies moving away from us. This expansion suggests that the universe had a beginning and has been expanding ever since. The future of the universe is uncertain, but astronomers continue to explore, unraveling its mysteries and pushing the boundaries of our understanding.